the equivalent of the unknown, where all of human understanding and basic principles just poof. What I'm talking about are black holes in space. So as a child, I've always been interested in astronomy. I'd always keep myself updated with NASA's new discoveries and facts. I love to hear new things about it. And so today I'll be talking to you about my favorite part of astronomy, black holes. So black holes initially were stars, and stars are always in a perfect balance between radiation and gravity, the inward pressure of gravity and the outward pressure of radiation. Once stars begin to die, radiation lowers and the gravity pressure wins, squeezing in the star and exploding it. Then it becomes a black hole. However, not all stars become black holes. Our sun, for example, would not become a black hole. A star has to be at least 2.8 times the mass of our sun. And then that's when all the interesting facts come in. So in Valerio Bozza's article, Gravitational Lensing, he states that black holes can bend light, winding images around black holes several times. So in theory, if I were to be standing in front of a black hole and looking off to the right of it, I could see the back of my head. It's crazy, right? So this comes from Einstein's idea of general relativity, in which space-time has curvature. Just like in this image here, if you were to take like a sheet of paper and have a ball that's really heavy, you drop it in the sheet and make a hole, just like the Earth is doing here in this little grid. So if I were to point a laser right on the right side of that Earth here, it'd curve the laser just like in the grid. So as for black holes, with the mass super strong, it makes a hole super deep and makes it more of a steeper rim, making it more of a 360-degree bend of light. So that's why the light would reflect off of the back of my head and come around to my face and meet me. Just like this image here. This is an animation of Earth rotating around a black hole. As it reaches the top right of the black hole, you can see it on the bottom left side. Also, note how dark, how empty the black hole is. This is an animation, but in NASA's actual telescope images, it is actually as dark as this. However, the only difference is there's so many stars around, it makes it confusing to see which stars are reflecting where. And so, there are many theories as to why it's so empty, why is it black. Han and J. Pugh tell us that it has been proven on how black holes are not black, but radiate thermally, like a black body, making it seem black. In 2014, Andrew Grant brings together ideas in The Mysterious Boundary to show how particularly strong black holes' gravity is, pulling in things that can never return. So what happens is, since black holes' mass are so large, their gravity is so strong, meaning once light goes in, it can't reflect and come back out. So that's why we see black, because light just isn't strong enough to pass the gravitational pull. And so, another theory of why this is so black is time. In Finite Gravitational Time Dilation of Black Holes, Andrew and Joseph Worsley talk about how significantly slower or even stopped time is when in a gravitational pull. For example, here on Earth, if you have a clock here on Earth, your clock is slower than a clock would be on a satellite orbiting Earth. So for a black hole, once you get closer to the surface of the black hole, which is called the event horizon. Once you get closer to the event horizon, time is basically stopped. So if an astronaut were to be going towards, if I were to be watching an astronaut go towards the event horizon, if I were to watch an astronaut go towards the event horizon, I would see him slowly float away, but never reach the event horizon. Because for me, time would stop. For him, time would keep going and he'd get into the event horizon. Now on top of that, he also wouldn't survive, because in Science News, Erica Engelhop defines a process called spaghettification that does exactly that, spaghettifies you. If an astronaut were to be going towards an event horizon, his feet would be pulled by the gravitational pull first, and his head would stay in place. So he'd stretch like a noodle. And so then, that other theory also applies, and it is in complete it's just arguing whether it's time or if it's light that makes you not see the astronaut reach the event horizon. Because also, if he's going towards the event horizon, light can't go back out. So it is argued, does he fade away into just ghost disappearance, or does he just stop? No one knows what's behind this event horizon. It is the complete unknown. No one knows if it's a wormhole, just traveling through, if it's teleportation, or you can travel at the speed of light. There's ideas that you can cross dimensions or the universe, making it, let's say I poked a hole through this paper, being the black hole. They say that there is a white hole at the other end that spits out everything that goes through. So it goes to the other side of the universe. In conclusion, black holes are crazy. No one knows what they are. They surpass human understanding. There's so many things to learn about it, and I really hope that humans are able to advance technology and find out what they are and understand time as more than just a concept.